This is a eighth session in the row. We have been taking it for last 1 month, 1.5 months, which is like getting separate modules covered, which will be helping us writing the AZ-204 exam. This session will be conducting by me. I'm Rishav Chatterjee, working as a developer in 366 Pi technologies. I mainly work on React and .NET tech stacks. I'll be covering uh, topics in Azure. So today's session is on exploring API management, which is eighth session. And after the session, we'll be conducting a Q&A. So if you people have any doubts, you can share it out there. So the chart for our next session is on 25th, which is developing event-based solution, and hope to see you there then. Moving on. So implementing API management. Uh, so the objective for this session is to learn the service which Microsoft provides for managing APIs and what we can do to secure them and how to create a, and after the session we'll be deploying a backend API with .NET 6 tech stack, and we'll be deploying that in an Azure app service, and then how to create a link or add a API in API management. We'll be going through that, and what more services and functionality API management provides us on top of our bare bones API that we will be building in API.NET. We'll be seeing and going over that. So the main components in API management service are, the first one that comes to mind is API Gateway. So API management does the same thing that its name suggests. It manages our API endpoints. And let's say we have multiple number of APIs in our solution or in our organization that we have built, which caters to different front-end services. So it's a very hefty task to go ahead and create separate, like manage it in code, like redeploy it every time a small changes occurs, or a basic example would be to even secure it via JWT tokens or OAuth, so, or anything like that. So mainly we tried, it's a very hefty process, and that's where API management service comes in. It secures our web endpoints, and it also uh, tries to manage it. So how it manages it provides us with a API gateway. API gateway serves multiple number of functions. It is a like main crux of API management service. It sits between as a middleware between the API which we create and a front-end API that API management service gives us. So there is this two parts. So there is in API management lingo, as per se, there are two parts. One is a one uh, terminology is the backend API, and another API, another terminology is a front-end API. And between that lies our API gateway. What we mean by our backend API is the API code the developers write or we write to for a specific solution or to access some specific data. So that is our code, and that is called as backend API, which we deploy in Azure app service or functions or anywhere in Azure. So that is a backend API. And when we add that endpoint in API management service, we get something called a front-end API, which will be the front-facing uh, front-facing API that we will call to access that backend API. And underneath and between those two services, there will be a API gateway. Things will get more clearer as we move to next slides and get hands-on with the dashboard. But this is a general overview of what API gateway is. And in the API gateway, we can declare many kinds of policies, many uh, routes, and how to route the request through our backend API via the front end, calling the front end API. We can check, we can combine and we can combine different APIs and call them out via our single front end API. Uh, these are some functionalities that we get via API Gateway. What Azure Portal is, this is the front view of our API management dashboard. So when we open API management, we get Azure Portal and we configure our API management service account and uh, different services that we want to access via Azure Portal. And another thing that we get, which is mainly from, uh, which is mainly from API management service, which is the developer portal that we get. Uh, it is a different, it's a website altogether, which we get, which is auto generated and we can configure it as per our needs uh, by like, it gives us the schemas of the APIs that we have and other example requests and stuff like that. We can configure it. It's a and that API developer portal can be accessed by other developers or the people who want to consume the APIs that are declared in API management service. So that's the place there they will be working on. And the Azure portal is a place there where the administrator for the API management service will be uh, using. So these are the two uh, differentiators in API management or hierarchies, you can say, in API management service. For the developers who want to just consume the APIs that are already built, they will be using the developer portal, which is kind of like a documentation website. And the Azure portal is for configuring those API endpoints via the administrators. They can add, delete any number of endpoints or do resource allocation or add scale the API management service, how many calls that are being made, they can manage that in Azure portal. So these were some components. Moving on to gateways, which is again a very important concept. So gateways gives us ability to route using reverse proxy to route requests to one or more backend services using layer 7 routing. So backend services is the same thing that the code that we wrote. So when we add an API, we get a, front facing or front end service which we call, and that front end service gets routed and calls another the backend service. So that is done via gateway routing, and we can combine different kinds of different APIs in using the routing mechanism that we can use. These are just exploring gateways as per our needs. This is nothing. This is not something that we have to use. We can. This is basically a design choice. So these design patterns do exist, and we can use or don't not use it as per our needs. So we get gateway routing, and then we get aggregation, which is always also uh, a gateway functionality, which is aggregating multiple individual requests into a single request. We can by in reverse proxy, we as in when we request a single endpoint, it via the gateways we can declare policies so that it requests different other endpoints. So that way we can aggregate so that the calls between the APIs are minimized. We just make a single call and we get the data uh, that is fetched via API gateways. We don't have to refactor the code or make some changes there. So let's say we have already made an API, which are different APIs, one or two APIs, and we want some data to be joined via both of them. We don't have to write a new endpoint or something. We just add that API and add a policy or something in the API gateway, and it will make that call for us, like joining the two data and presenting it to us, like calling it multiple one after the another. So that was aggregation. We can also do gateway offloading, which is offload functionality from individual services to the gateway, particularly cross-cutting concerns like authentication, IP allow or block, or client rate limiting. So these are some functionality that we would like in our APIs, like authentication. Authentication is something that if our data is not open, we absolutely want it to be authenticated. So only the authenticated users could access those data. So, and again, implementing authentication is, we don't want to do it every time that we declare an API. We can just leave it to API management tool to do that for us. So authentication, IP allow and block. So we can allow or whitelist the IP to be accessible to calling that endpoint, and also rate limiting. And there are many other offloading uh, policies. We can refer to Microsoft documentation for that. Rate limiting is calling a endpoint a set number of times as per the policy need, so that we are not vulnerable to DDoS OS attacks, like spamming the endpoint and making uh, like creating burden for the server. So we can rate limit, uh, and that is also can be declared in Azure API Gateway. Moving on, here is a picture or a diagram for API Gateway. We can see these are the client apps, and the client app will directly be calling the API Gateway. The front-facing API that we get gets auto-generated when we add the services to the API Gateway. We will be calling that, and not the APIs or the services that we wrote. So earlier, the typical way that we do is we make a client front-facing app and a service, and the client app will be directly calls the service. And but now here we in the API management tool, we box that in a single box, and will be not be calling the service, but the this API management tool via the gateway. It so the gateway takes care of identity provider. It acts as identity provider. It can use Microsoft Azure authentication or OAuth or any other particular authentication method that we wanted to use, and then it can route to service A, service B, as many services that we want. But we are calling a single gateway. It can cache the responses. We can check the logs, which API was called when. So that all can be provided. So before we move on to management policies, we first we can go ahead and look at in the dashboard how we can create a API management service. So let's move on to Azure. So going to Azure portal homepage, if we search API management, it opens up a window and we create an API management service. We fill up the form. Uh, Source scope will be session 8 region. Organization name, email. And we have the pricing tier for us to get an idea of what we want the scale for our API management service to be. So referring to that, we have, we can go to say, Here we get a calculator of the region, and the price for our service resource gets differentiated by the region that we select. So as we can see in East US2, we get for the developer, let's say hourly basis, five rupees per hour. So if we select in Asia, it changes. Yes, it changes. So let's select Central US, and we have developer, basic, standard, and premium. So for our needs, we'll be selecting developer, but as we can see, price jumps a lot if we uh, as per our requirement and needs. So uh, we have to make sure what we need and then create API management gateway. Then moving on. So I will not be creating this resource because I have already done it. It will take at least an hour or so. Maximum is 2 hours. So that's why we will be just going on to the already created API management service and not creating a new one. So this was just to show how what are the options that we get for creating when we go ahead and creating a new resource. So we get managed identity, which was covered in the last session. We can integrate it also with our API management gateway so that we don't have to we don't have to declare our configuration SQL configurations in our code. So this was the page for creating a new one. So going to the already created resource, we'll be opening that. So its name I've kept as my API manager 8. So this is a front view of our page. Then we have all the items here. So main thing is the APIs. And we get presented by a default API that gets created just to test the functionalities. So this is like the view of our API gateway. Here is the backend. This is the front end which will get called if we sorry for that. And this is the gateway that we talked about. Here we can see we can declare policies. That will be the next slide, which is declaring, making conditions and filters on data, which and we can place that filters in inbound request or the outbound data that we get from the backend API. So this is the backend API, and we'll be calling this. Let's say to call that we move to test and just send. We have different parameters. Then click send. We get a 200 message, so it passed through, and we can check the trace. So while clicking trace, we can see which all URLs it got hit and how do we get the data. So currently we already only have one URL, which is the API manager and the echo endpoint, and it gets passed all these data, all these request headers. Uh, yeah. So moving on to the our next topic, which is policies. what policies does is it's a very powerful capability of the system that allows publisher to change API behavior through configuration. As we don't have to write any code. Yeah, we have to write code, but in XML as a XML document and not in our tech stack that we deployed our backend service in. So that's the thing. So we don't have to write code in different APIs and go change that. We can make change in a single gateway or a single uh, the change that we need in a single as a single policy, and it will get carried out to it will make sure that the data that we get uh, conforms to those conditions. Next is policies are collection of statements that are executed sequentially or request on request or response of the API. So we have uh, general tags for outbound, inbound, on error, those kind of things will and then we declare the statements that we want inside those tags, as we have seen in a web config document that we have in our .NET projects. Policies are applied inside the gateway, which sits between the API consumer and the managed API. The managed API is the resource, the code, the bare bones core API, and the API consumer is the API that we call. So that becomes the consumer. The front end API becomes the consumer of the backend API. The backend API is the managed API. These are just some terminologies that are used here. So in those gateways, we go ahead and declare the policies that we require. Then the policy configuration is divided into inbound, backend, outbound, and on error. Here is an example of a sample XML policy that we get. We can edit that and save, and it will be applied to our API, front-end APIs when we call that. So the policies are inbound. So inside inbounds, we write statements to be applied to the request we write here. Inside backend, we have statements to be applied before the request is forwarded to the backend service go here. So after inbound comes backend. So the request will go to inbound first, and then before reaching the backend server, the backend tags will get hit. And after the request is processed by the server, we get to the outbound tag. And after the outbound, if any error happens, we get to on error tag. And now if nothing happens, we get the data back. So these are some policies. And another thing that we is very useful in API management services is if we, let's say we have written APIs in many different tech stacks. One team is working on Python REST APIs, one in WCF legacy code, and one in .NET 6. So we don't have any of like we have to declare or host deploy app services also in those particular tech stacks. But let's say we have to merge them somehow. So my API management services, we can take help from it, and we can like deploy, we can add those services in the single text, like just by the endpoint basis. We can see when we come to our API tab, we get many options to choose the destination from where we want to host the API. We have app service or like manually defining the HTTP API. I'll be creating a .NET project that I already have. Yes, it's a simple .NET project. I will be deploying it and creating an endpoint, HTTP endpoint manually. So moving on. So it tries to merge the concepts that they all these APIs have in common. which is a endpoint, which is the endpoint. So let's say it can be the Python API is written in Python or in .NET or in other Java, something like that, or in JavaScript. But they all that have in common is they all coerce or they all maintain the HTTP protocols that they need to communicate between the web server and the client. So that HTTP protocol is used here to like define layers upon the already built APIs. So that is the functionality that we get from API management service, which is like building on top of a like layering on top of a already predefined protocol, which is HTTP. So how do we secure an API? So as we could see when we called this endpoint, uh, when we come here and test it, let's say, and we again go to trace. Uh, we see a header that is passed, which is called OCP APIM subscription key. So if we try to go ahead and use this endpoint and call it via Postman, let's say I create a new request, and I just send it. It will say access denied due to missing subscription key. Make sure to include. So by default, we get us an encryption or authentication mechanism for our front-facing API. We don't have to do anything. That is on by default. So only when we pass this data via our headers, only then we can access the resources. We will see that when we try to access the deployed API that we have. So let's deploy this API. So I'll be using FTP to uh, deploy it. So this is the default code that we get. We get an endpoint which is weather forecast, and we can call that endpoint to get some predefined data in. So let's say I build this project. Publish it. Now let's open FileZilla FTP connection software, transfer software. I've already created the connection to our app service and declared the host and the password and username for that. as the files got uploaded, we can be sure that our uh, application web API application got deployed. We get a status 200, and this is the endpoint which we created as a developer, which is, and we are posting it in this URL, which is my weather API 8, which is the name of our app service. And this is the endpoint that we have currently, which is the weather forecast. So we'll be trying to add this in our API management service and declare some policies on top of it. So how to add it? We can add it via the app service or the HTTP. I'll be going to manually add that right now. So let's say I want to give it a name of and in web service URL, we give the base URL for our site. And this is the auto-generated base URL that we get. So let's create. Here we can see there are no operations currently. So we add an operation. Explaining. So which resource will it want to fetch from our backend URL? So the URL that we declared was the resource URL. It's a site URL, and here is a example of how to we can provide different kinds of different URL parameters as per the resource requirements that we have. Uh, we'll be giving weather forecast. That will be a resource that we want from our declared given site URL. We check the method HTTP method that it has. It's get, so that's good. So saving it. So in front end, we just get slash weather forecast. We don't have to have any relation to this app service or anything. We just give the end user this front end URL. Some benefits for that we will see is this will be the request URL which now is generated. Our API manager, my API manager 8, which is API management service, and then this is the resource that we want to access. This is the breakdown of this URL. So here this is the front end API. We'll be calling this first. So if we send the data, we get the uh, our weather data back. But we are calling this API, not the one that we created. So let's say uh, we go to our Postman and I try to call this here. It will say access denied because we have not set a key in a token or a key in our headers. So that is missing. So how we can do that is, so this is a much more secured way than handling bare API endpoint to our user. So if we go to trace for this request, trace, yeah, we can see it first calls this endpoint and then it refers to this forward inspector, which is this. This is a forward request, which is this is the backend, and this is the inbound front end. You can check that which request and which headers were passed via this JSON document, and then response we get the outbound. So let's say we want to use this data. So how do we pass that? As we get the headers, this will be the key to the value. Now we get all the data, but just to be sure, we are not securing this endpoint, which was our default endpoint or the backend endpoint. This is, of course, open as we have coded it ourselves. We are not securing this as per se. We are securing the front end endpoint, and this is the endpoint that we give it to our end user. So let's say we have moving on to subscription. So subscription is what we just witnessed. This is the default subscription that the front end API gets when we uh, use the when we try to add an API endpoint. So to consume the published APIs must include a valid subscription key in the HTTP request when they make calls to those APIs. We can add another subscription key or anything on top of these. To get a subscription key for accessing APIs, a subscription is required. A subscription is essentially a named container for a pair of subscription keys. We can also use other methods like OAuth 2.0, client certificates, and IP allow listing is also supported. So these are some security features, and we also have scope for those subscription. So do we want to apply that key to every API that we add in our app API management, or just a single API? And there is also something called a product, which is a collaboration or collection of many APIs into one. So this scope apply this all APIs applies to every API accessible from the gateway. This scope applies to single imported API and all of its endpoints. A product is a collection of one or more API that you configure in API management. You assign APIs to more than one product. Products can have different access rules, usage quotas, and terms of use. So these are scopes that we can define on our API endpoints. Securing APIs with certificates. We also can issue certificates as uh, differentiating from our security keys. Certificates can be given, like we can issue it, so we get these data points which are who issued the certificate, who's the subject, and this expiration date. So we can filter out data or allow certificates signed by particular certificate authority, or the thumbprint, or the subject, or the expiry date. So these all features we can use in Azure API management. So concluding this session, I would like to add a policy to our endpoint and have a look how it helps us. So previously, we could see that uh, how to add policies is we go to design, and we have inbound and outbound gateways here. So just policies or add a policy, we get this XML file, which is inbound, backend, uh, outbound, and on error that we just saw an example. So how do we know what to write? So we go to API management, refer reference manual. We have all the policies that we get in API management tool resource in here, and we can check what we need, and the code that we have to write or the syntax for that can be referred from here. So we will be using a limit call XML limit call policy, so that we limit the number of times a user can access the endpoint in a particular amount of time. So there are many other policies that we can use, or like modify that as per our needs that we want. So here in rate limit, we have two or three attributes, which is calls. So calls is how many number of after how many number of calls we want to uh, restrict it. So here it is 20, and for how much time we want to restrict the user from accessing the endpoint. So as it gets hit once, so be uh, it will be not accessible for 90 seconds. This is seconds units for renewal period. So after 20 calls subsequently, we will be restricting any access for 90 minutes. After that, it will be open again for 20 calls. So by this, we can like prevent some attacks like DOS attacks, where the server gets overburdened with like millions of requests per second or minute. So I'll be just copying this code from here and pasting it. Side bound. And another thing that we get from API management is the versioning, which is we can see here it says revision 1. So for versioning an API, we want to add some functionalities to a different version. We can change that by coming to this tab, which is revisions. Here we can see the version which is currently online, and which is the current chosen version. So the current version is that which will get hit when we call that endpoint. So currently it is this one. So if I add a revision, let's say, so there are two things, which is revision and versions. So revision is something that will automatically this endpoint will get updated and it will switch to current. And version is something that we can test it out locally before making it the current version. So let's say we want to make another version, which is V1. And this V1 will be attached to our parameters. Here we get a nested version 1 and original tab. So for this single endpoint, we have two versions that we did just via API management to keep laying that out. So a single version can have many revisions on itself. So if you want to version scheme, so let's say I declare the call limiter in version 1. I limit it to not 20 but 3. Renewal period in 5 seconds. Now let's test it. It gives a 200 message. So it passed through. So let's spam it some couple of times. It says too many attempts after 3 consecutive attempts, and it says try again in 8 seconds. So if we try again, it will say, so 10 seconds got it. Try again in 6 seconds. So this is a call limiter that we efficiently, just by a few one line of code, we applied to our endpoint. So that I think is a good thing to have. And we have many other policies like that to be added to our endpoint. But this endpoint is again our previous version. This doesn't have that policy. So, and we can see our endpoint got changed when we tested, and version 1 was added to the parameters. So the request URL was version 1 weather forecast and not just weather forecast. As in here we have, which is just weather forecast. So that was it for today's session, people. So thank you for joining. Any questions? Okay, so I guess there's no questions. We stop presenting. Thank you guys for joining this session. Uh, have a great day ahead. Goodbye.
Thank you, Rishabh.
Thank you.